next presenter will be Pol Arias, who will present the work Routing Fleets with Multiple Driving Ranges. Is it possible to use greener fleet configurations?
Good morning, everyone. My name is Pol Arias. I'm going to present this work, which is a collaboration with Angela Juan from the IN3 of the UOC, Jarrod Gonsel from the MIT, and Tolga Bektas from the University of Southampton. This is the content of my presentation. I'm going to go through the context and motivation, why we do this problem, why we tackle this problem. An introduction of the vehicle routing problem, which is the main base problem that we are going to solve. I'm going to go further in my problem and explain what's heterogeneous and what's green VRP, what's the green vehicle routing problem. Then I'm going to explain more or less how we solve it. I'm not going to go in deep in the process, but I'm going to more or less try to explain it graphically. And then some results that we achieved, and finally the conclusions and future research. Why we do this problem? Why we chose this problem? Well, you know, companies nowadays want to go greener because there's this environmental problem, and then the companies need to improve their technologies. In our case, we are tackling the routing problem. How can we go greener in a routing problem? Well, you know, we want to reduce this carbon footprint. It's very important in these environmental problems that we have nowadays. Also, there is the cost risk of the fuel. You know that there's a lot of uncertainty in the fuel. It can rise a lot or it can go down. Now it's down. Hopefully, it's going to stay there a while. Then we have these new government subsidies that we get for the companies to get greener. And also, the advances in these technologies make it possible for companies to make this step, to go further and get greener. But what's the problem? Why companies don't do this? Because we have these two kinds of vehicles, the ignition ones, the normal ones that we drive every day, and also the hybrid ones, for example, that nowadays some people use it a lot. They have unlimited distance range. So you can drive as far as you want because you can refuel in any station. But what happens with electric vehicles? Electric vehicles, you do a route, you run out of electricity, and then what? You don't have that many stations that you can refuel electricity, and also you need time to refuel this car. So this is the main problem that we encounter in tackling this problem. So can we do this in a way that the companies can use greener vehicles? We will see. What's the vehicle routing problem, and what's the rich vehicle routing problem, which is a step further on this basic problem? Well, the vehicle routing problem is a combinatorial problem. It has been studied a lot since 1959. You have a set of customers that you want to serve using a fleet of vehicles. And what happens when you have more constraints, more real-life constraints instead? Then you have the rich VRP problem, which we studied with Jose Cáceres. I don't know if he is here today. That adds real constraints to this basic problem. For example, in our case, heterogeneous, green VRP, open routes, which you can end in any of the customers, pickup and delivery, and so on. There's a lot of new constraints that you can add, and it gets difficult and difficult and difficult. What's our problem, though? We have heterogeneous and green. What we mean by heterogeneous? Heterogeneous is that you have a different fleet of vehicles. In our case, we have electric vehicles, ignition vehicles, internal combustion engine, and hybrid vehicles. What we mean with green VRP, we want to take into account this greener aspect of this vehicle routing problem by having these electrical vehicles that you can only use in certain distances. This helps in the fuel consumption because you only have electricity then, and then the electric engines, you know, it all is more environmentally friendly. Also, what's the objective of this problem, of our problem in this case? We want to minimize the distance cost of using the greenest configuration, the distance cost with how can we optimally do a route by minimizing the distance. We have here an abstract of what mathematically speaking, this problem looks. This is a small part. It's long and long and long, and it's really difficult, so I'm not going to go through it. But yeah, it is quite difficult to understand. Also, how we solve it. There's quite a lot of different ways to solve this problem, but with Angel, they did this kind of algorithm that takes step by step. You have the whole problem first. You're going to have, the first step of all, you have these 2 ignition vehicles and 3 electric vehicles. How do we solve this problem when we have all these nodes in the number 1 and these 5 vehicles? Well, first we take all the routes that we can do with only the ignition ones that don't have this distance restriction. And then you solve it optimally and you have these routes. And then you take the longest ones that you can choose out of all the solution. Once you have optimized the long range vehicles, you go to the next step, which is you subtract the nodes that you already have put into use, and then you have these 3 electric vehicles that you haven't used yet. So what do? You optimally solve this problem by putting these nodes to each vehicle. You can see that they are like smaller routes than the ones before. And then, finally, you just put together the 2 problems that you solved, and you have the final optimal solution, which can be seen in here. This problem, what we achieved with this? Well, down there, you can see all the table of results that I'm not going to say, but we have really good results. Even we beat some benchmarks that nowadays circulate on the internet. But for us, the main point of this work is how can you improve the greener aspect of this problem? We have this green rank that we said we had. For example, you know that in the first picture you have 180. This means you have 1 electric vehicle, 1 hybrid one, and 0, for example, ignition ones. And then when you are changing this configuration, you go greener, because the more electric vehicles you use, the better it is. And sometimes, if you use 1 ignition one, but you use more electrical ones, it's still better, environmentally friendly. But the interesting point is that the cost of using greener configurations doesn't increase that much. So we don't lose, actually, that many distance costs between the benchmarks that they don't use green configurations and us that we use green configurations. So we think that this point is really important because we have this decision-making tool that you can choose different configurations and see, okay, I have this number of vehicles, should I use this configuration, how it affects the cost, and so on. In conclusion, I think we support the fact that we can use these hybrid and electric vehicles in the routing problem. I think also that the solutions are quite attractive enough for, I hope that in the future some companies might use it because it really helps. I think it's an important aspect of our day-to-day life to improve the environment as much as we can. And also, but we want to go further in our research and do the carbon footprint aspect. How to monetarily calculate the impact of our savings by using electric vehicles and not ignition vehicles. Also, there's this topography impact that we can explore. Some cars cannot drive some routes. Electric cars don't have the power to drive that far or with that many weight on them. And I hope in the near future we can just publish some more about it. Well, finally, I'm going to say that this research has led us to publish two papers in 2 really good journals, both in quartile 1, and I hope our group with Angel, we are going to continue publishing much and better. I hope you like the presentation. Thank you very much for listening, and Angel.